Hello guys, hope you're doing well, and as always, if you are new to my channel, I would humbly request you to subscribe to my channel and click the bell icon so that you shall be able to watch all my latest engineering videos that will be helpful for you in your future studies. Thank you. Alright, the problem at our hand today is basically a dot product problem, or you can say it is a scalar product problem. Okay, so what does the problem says? It says you need to determine the angle theta between the force and the line AB. Okay, so if you look at it, this is the force F and the line AB. Okay, you have to find this angle theta. Okay, so let's start to solve this problem. Okay, so if you look at it, this is our problem, and we need to calculate this theta over here. This is the theta that we need to calculate. But if you look at it also, that I have also added some more unknowns. You need to calculate the magnitude of force AB, which is the basically the projection of this force on this line AB. Okay, and not only that, not only the magnitude of force AB, but I am also asking you to calculate what will be this force vector AB, not projection, but what will be the vector FAB will be. Okay, so we have basically here to calculate the three unknowns. Okay, so let's start by solving the problem. The most important thing over here is that we need to calculate the coordinates. That is very important. And if you look at it, our coordinates of A, you have to calculate the coordinates of B, you have to calculate the coordinates of C. If you look at it, for the coordinates of A, basically what we have to do, this is, remember, this is our origin 0 comma 0 comma 0. Okay, so first say we calculate A, so A will have, what will be the value of A? X. Okay, so on A the value of X will be 0, and the value of Y on this A coordinate will be 3, and the value of Z will be 0. What about B? Again, this is our origin. Okay, what will be the value of X when taking about B? It will be 0. The value of Y will be 0, but on B the Z value will be 4. Okay, so it will be 0 comma 0 comma 4. What about C? On C, if you look at it, your X value will be basically 4, but your Y and Z values will be nothing. It will be, the Y value will be 0 and the Z value will be 0 on calculating the C coordinates. Okay, so if you look at it here, again origin is 0 comma 0 comma 0, the A coordinate is 0 comma 3 comma 0, and the B coordinate is 0 comma 0 comma 4, and the C coordinate is basically 4 comma 0 comma 0. Okay, so these are basically our coordinates which we have just discussed over here. Okay, so we, another important point is that line can be anything and in the direction of any structural member like strut, shaft, column. You could treat any of these can be treated as a line, whether it's a strut, it's a shaft, or a column. They all can be treated as lines, which basically are basically force bearing structures. The strut, if you take it, your column, you take it, your shaft, they are force bearing structures. Okay, they will bear some kind of forces. So these coordinates are here being explained. So we need to express the forces in IJK formats as well as in the unit vectors. Very just to tell you a brief approach, one, you can see this force F is basically in scalar. Okay, so but we have the coordinates of A and we have the coordinates of C, so we can transform this scalar force 600 Newton into Cartesian vector form. Again, A and B constitutes line AB. We have to basically take a unit vector on this line AB by taking the position vector AB divided by mod of the vector RAB will give you the unit vector AB. So these things are just explained here. Let's see how we are going to practically do it. Okay, so just look at it. First of all, we calculate unit vector AB. It is basically RAB over mod of RAB. Okay, so what does RAB means? It means you have to calculate, start by taking the coordinates of section B and subtracting it from the coordinates A. Okay, so unit vector AB, if I go previously, this is A and this is B. So B coordinates are 0, 0, 4 and A coordinates are 0, 3, 0. So you can see in AB case, it will be 0 minus 0, it will be 0, so I will be 0. What about this one? This will be 0 minus 3, so it will be minus 3j. What about this one? 4 minus 0k. So the coordinates that will be coming now here is basically 0i minus 3j plus 4k. But mod of RAB will be 3 the square and 4 the square is basically minus 3 the square plus 4 the square is nothing but 25. So unit vector AB will be 0i minus 3 upon 5j plus 4 upon 5k. Okay, this was the position vector AB. This was the position vector AB mod taken under the square root and square of the values of 3 and 4. It's very simple. Now, as I told you, the next thing is that we have to transform this 600 Newton force into Cartesian vector form. Okay, this is a scalar force. So you can, what we can do in order to transform it, we will basically use the vector F will be the magnitude F into the unit vector AC. But what is unit vector AC? It is nothing but position vector RAC divided by RAC mod. Okay, so here again, where are these values coming from? We have to calculate basically first the coordinate C, and then basically all the C coordinate values will be subtracted from A. Okay, so what we will do, as it is RAC, so basically RAC, so C coordinates minus the A coordinates, so 4 minus 0, 0 minus 3 and 0 minus 0 k. Okay, so 4 minus 0 will be the I, 0 minus 3 will be the j, which is minus 3j, and 0 minus 0 will be 0k. So you can see it is 600 4i minus 3j plus 0k. Okay, so very simple, 4i minus 3j plus 0k. And again we also have to take, this is the position vector AC, we have to take the mod of this RAC. It will be nothing but 4 the whole square plus minus 3 the whole square. 0 will be 0, you won't need to square it. So just simplify it, you will be getting it as a multiply with this, you will get 600 4 upon 5i minus 600 3 upon 5j. So now you can see basically this magnitude F has been transformed into vector F by using this formula. Okay, and the end result is this value, 600 into 4 upon 5i minus 600 into 3 upon 5j. Let's proceed further. And basically we are now interested in calculating the projections of this F. Okay, so if you look at it, sorry, we have to first calculate the angle also. So the angle between the tails of UAB and F is using the dot product. Okay, and we already know the dot product formula is basically vector F dot unit vector AB is equals to magnitude F into unit vector AB into cos of the theta. We have already given you the value of F in the question, as a magnitude is 600, and again the unit vector AB magnitude will always be 1. Okay, so the magnitude of this unit vector AB, this will always be 1. Okay, if you can do it also. This magnitude will always be 1. Okay, and then if I go further, what is about this vector F dot UAB? Okay, we already know the values of vector F and unit vector AB previously also. If you look at it, this was our vector F, 600 4 upon 5i minus 600 3 upon 5j, and this is unit vector AB. Okay, so if you look at it, when we basically as you can see, we basically have to take the dot product. Okay, the end result of this will be a scalar value. So when we take a dot, okay, so when we take a dot, it will be 600 4 upon 5i into 0i, so it is nullified. What about this one? Minus 600 3 upon 5j dot 3 minus ka 3 upon 5j. So this will be basically, we can successfully calculate the dot product of the j's, but the 4 upon 5k will have no partner over here with F, it will be just 0. Okay, so we will be interested in basically the j components of both F and UAB. So you can see basically unit vector AB basically and basically is minus 3 upon 5, and force F is minus 600 into 3 upon 5 j, and j the angle is 0, so it means it is 1. Okay, so over here it is. Okay, so this is minus 3 upon 5j and this is minus 600 3 upon 5j. That will be basically explained further. Okay, so just multiply this two values, you will get 216, and you multiply 600 into 1 into cos theta gives you 600 cos theta. Simplify, you get your theta as 68.89. Okay, so once you have got this theta, is basically you can now also calculate the dot product also very easily. Okay, so if I come here, uh, basically the projection of f on AB, the projection of f on AB will be this. FAB will be equals to, again this is the magnitude, will be vector f dot unit vector AB. Okay, and if you go previously, we have already calculated this value. If you go here, we have already calculated this value. Okay, so again this vector f dot unit vector AB, if you look at it, is basically uh, this is our unit vector AB, and this is vector f. Okay, 600 into 3 upon 5. Okay, so again these are the vectors, and just to let you know, this was minus and this was minus, minus minus when multiplied it gives you a plus. So force AB comes out to be equals to 216 Newton. Again, this is the parallel component of force AB. And if you want, you can also calculate this force AB in a different way, as by just you be using like this also. This force FAB will be equals to, give you the same answer, the force F into cos of, what was our angle that we have calculated previously, what was the angle, 68.89. Okay, into cos of 68.9, say. Okay, so this was the angle that we have calculated. If you look at it, this was our angle. So if you multiply f with this, you will still get force AB equals to 216 Newton. Okay, so this and this are the same. Okay, so if you look at it, this is exactly the same that we have gotten over here. Okay, now we are basically being interested here. If you look at it, we are also interested in making this FAB, which is a scalar, into a vector FAB. So what we do, we have to transform this FAB into vector by transforming it into Cartesian vector form, means IJK format. Okay, so this is the formula we use. Vector FAB will be equals to FAB mod into unit vector AB. Okay, so it will be FAB mod into unit vector AB. But what is FAB mod? What is FAB mod? It is simple, 216. And what is UAB? UAB is nothing but it was RAB upon RAB mod. And remember, we have already calculated RAB upon RAB mod as 0I minus 3 upon 5J plus 4 upon 5K. Okay, so if you look at it, you will basically be, so basically we will go to multiply FAB with UAB. Okay, and but FAB is what? FAB magnitude is 216 into 0I of UAB, and then minus 216 into 3 upon 5J plus 216 into 4 upon 5K. So your basically vector FAB comes out to be minus 129.6J plus 172.8K. Okay, the zero for the I was basically 0, so there will be no I component for this force FAB. I hope you have understand this, and thank you very much.